and a little bit about me is graduated from University of Anchorage, Alaska. One of my claims to fame is I graduated in the top 10 of my class, which is true, but there was only 6 in my graduation class. So, but I've been volunteering with EMI for 25 years. All I've ever been is a consultant engineer. And I'll say, without a doubt, I'm a person that faults on the technical side of things because I really like doing things well. I really like the engineering aspects. But it's important to note that there are some things that can be offered on EMI trips that other groups can't do. So here's a couple pictures. I love this picture of Shanna here because since I go back to Cambodia, sometimes the little kids recognize me. But I like this because she has a sports top on the front and pajamas on the bottom. She has 2 outfits, and this is one of them. So not everybody can rock a sports coat and pajamas at the same time. But I was also there a couple years ago at Stray Knees' last few days of life. And that the opportunity that I had to pray with her, is something that not all organizations could do. And there's a whole story and a lot of pretty amazing things that came out of that story. Also, kind of a side note one time, when I was in China, I was actually told by a local that he was saved by wastewater. And I said, "What are you talking about?" So I had the interpreter re-ask the question, and he said that he became a Christian because of wastewater. And I said, "Well, still, what are you talking about?" So come to find out is that he lived in a lower village, and all the past organizations, whenever they had wastewater, they would just allow it to roll down the hill. And but when this Christian organization went in there, they actually cared about the wastewater. And since they were taking care of the wastewater, taking care of the environment, this person was so interested in what Christianity had to offer that, believe it or not, he became a Christian, and a lot of people in the area became Christians after he became a Christian. So the point of the story is the work that we do, it's really difficult to know, what the true future of it is. So today I'm going to be talking about sanitation and bacteria. I'm going to talk about design world compared to the majority world. So the type of waste disposal I'm going to talk about today is septic tanks and leach fields, pour flush toilets, composting toilets, and biodigesters. But there are other types of disposal types such as lagoons and wetlands, mound systems, ETA systems. So don't think that this is all that there is. Okay, so this slide I think is a very eye-opening slide because when we do what we do, a lot of times we think that if we put in a toilet that we've done our part and that then everything would just be fine. But this is a study that was done in Bangladesh, and what it showed is they in this area they showed that 20% were connected to a sewer, 79% had an on-site facility, and then 1% was open defecation, which, by the way, in rural Cambodia, they have 85% open defecation. But what this shows is even though they were connected to a sewer, even though they had toilets, bottom line is 98% of the fecal sludge was ultimately being disposed of improperly. So the whole solution wasn't figured out. So these are some pretty deep thoughts. And, I've seen a lot of very graphic things on my trips, but this is an example of a man that is cleaning out a pit manually, which means that he jumps down into the pit. I've been on projects where I've seen people down in septic tanks, bucketing out septic tanks. But also the picture on the right is a classic place of where they may pump the wastewater, which is good, but then they dump it in a place and it can go down through villages or go down into lakes. So it's just, there really is a lot to this. So the typical EMI design is a septic tank in a leach field. But imagine if there was somebody from China And they decided to come over to the United States, and they said, because they read about some poor country or area in the United States. So they decide, well, United States needs help. So in a rural area, they design a biodigester, and they design a squatty potty that goes with that biodigester. And since there's over 18 million biodigesters in China, they feel like that they've done a good job. But the problem is that in America we have abundant energy, so electrical energy is cheap, and most people aren't going to know how to use a squatty potty. So it just shows you the flip side, that where we have to be really careful that when we do designs in their country, we need to really understand in what their system is. The other thing I add too is here we commingle our wastewater and our sink water, so black water and gray water, and sometimes on EMI trips it's really beneficial to separate those two. Now, during this presentation I use the term wastewater all the time, and I just want to clarify that the wastewater that I'm talking about is basic human wastewater. I'm not talking about the real complicated wastewater that we have in America, which can be industrial waste and a lot of soaps, antibiotics, because if you put detergents and those kind of things in a septic tank, then it's not going to behave very well. So I'm using the term wastewater pretty loosely. Now, for us, we look at wastewater as something that's icky and we don't want any part of it, but you'll find that in different cultures that they make use of waste, and this is a very common thing. So, but what we're trying to do is we're trying to find a safe way to utilize this waste so that it's healthy for all. So on a typical EMI project, typical septic tank leach field, what we have is we have the septic tank, which is kind of the main part. We have a distribution box, and then we have these leach fields. And these leach fields are, it's very critical how these are designed, because they have to be really flat if they're going to behave properly. But we also have pipes that go to the septic tank, and we also have to have cleanouts in there. So I say all this because a lot of people look at biodigesters as being complicated, but even in what we do here, we have a septic tank, which is a pretty elaborate device. We have a distribution box, and then we also have a leach field. And in all honesty, my recent trips to Cambodia have been not only on the design phase, but also on the construction phase. And I found it incredibly difficult trying to work with contractors to build a leach field. On paper, it sounds so easy, but when you get out in the field and you're trying to work with a contractor and explain how these little invert differences make such a big difference in how to make this whole area flat, that I actually got fed up and went to a chamber because they sold them all over the place, and it was just so much easier. Okay, so although septic tanks are beneficial, there are other issues that EMI volunteers should think about before we just go putting in a septic tank. So here's some. What is the percolation rate of the soil? Is there rock? What's the height of the groundwater? Is there a well or water nearby? Is there enough area for the leach field and a reserve area? So, that's a heavy thought there, that when you may first think that you're okay with the leach field, but you also have to have a reserve area. What's the topography of the site? And then, the consideration is, can you have more than one type of system? And then also, is there a need for compost, fertilizer, or energy biogas? So the initial thought by most Americans is that poor flush toilets are terrible. But I'm going to challenge that, because I actually think poor flush toilets are great. But I think that they have to be designed properly. So what I've done is I've shown a couple of pour flush toilets here where I think that the design is really good because I like the raised floor and I like the fact that the water is nearby. But basically with a pour flush toilet, after you do your business, you take a bucket of water and then you pour it in there and then it flushes it through. And so what you see on the right, even though some people may confuse that with a Western toilet, notice that it doesn't have a tank on it. So all this is a thrown pour flush toilet. But the advantage of a pour flush toilet is it has no moving parts. It's very easy to maintain. And in America, most people would be very surprised if you knew how much water that we waste from leaking toilets. Sometimes it can be up to 50% of water being toilets out there that are leaking. So in America, where we have tons of water, this is not a big deal. But for us engineers in these places that are water scarce, if you have water that's continuously leaking, it's going to dry out your tank. Then you can have more energy cost. So it can be very complicated. And the flappers in toilets sooner or later wear out. So there can just be a lot of challenges to them. Okay, so here is a picture of a composting toilet. And so this is a concept. I have not done one of these on a trip yet. Now, ironically, some people in America now are getting into this in this concept. But with a composting toilet, what you do is after you, I'm using the term "do your business," so I don't know where I got that from. But what you do is you take some organic material and you sprinkle it on there. Basically, what you're trying to do is get rid of all the wet areas. And so when it comes to dry material, there's a whole bunch of different things that can be used, such as sawdust, dry leaves, grass, and so forth. And later, I'm going to show you why that's important when we talk about C/N ratios. So it doesn't require a source of water. It's odorless. It doesn't attract insects if it's properly used. It can be built in places that other systems can't. So like you could put this in a rocky area, you can put it in a floodplain, you can put it in a high groundwater area, you can put it close to surface waters. It doesn't need to be moved or rebuilt, which is really nice. And compost, if it's harvested, is a very useful resource. And urine, if separated, is also a useful resource. Now, the use of urine is a very tough subject, and that's also something that I have not done. But I want to talk a little bit about it because it's helpful to understand the C/N ratio in composting and how the chemistry works on all this. Okay, so the two main reasons for urine separation is that when you're composting, you really need that oxygen transfer. So the urine, when it wets the pile, really hinders that. And the other thing is that the C/N ratio for urine is really lousy, and I have a good spreadsheet that you're going to see in a bit that shows that. But ironically, urine can be a really high quality fertilizer, and the key is mixing it with water, 4 parts, and then sealing the top. But I also admit that the collection of urine to use for fertilizer, how are people going to deal with that? And it's something that I don't know, but I am going to put to practice on one of the projects in Cambodia. So the knee-jerk reaction is that this would be a really hard sell. But then also, like when people are out there, taking cow patties, for fueling, and they're doing that, then it makes me think that it's not such a hard sell. But how urine is separated is a lot easier than you think, and there's a lot of designs that are out there. So this is one that shows a false floor. And basically with this, the urine can go through the slats. And then there's also a diverter that you see right there in the picture. So here's a close-up of the false floor, and this is a very simplistic design. And in this case, the urine could either be wasted or it could be collected. But there's also other designs that are a little bit more innovated. And when on the project that I was at in Cambodia, it was really common that they had urinals all over the place at the back of the buildings. But in that case, it would be super easy to collect the urine. And then, but here, surprisingly, there's actually manufacturers now that are starting to manufacture toilets to collect urine, like what you see here. So where this goes, I don't know, but I think that it's good for people to be thinking outside the box. Okay, so what with compost, after I go through a composting toilet, the material is digested. It doesn't have a lot of odor. When you think of just using common sense, when you think about store-bought fertilizer, and when you put that on the grass, when you put that on dirt, how easy it is for that to wash out if it rains. And it's just completely different than when you put compost down, because when you put compost down, it binds into the soil and it becomes part of the soil a lot better than the chemical fertilizer does. So it has greater fertilization value than raw manure. I got a slide on this later, but I'm definitely not talking about night soil. So don't ever confuse night soil, which is the application of raw wastewater in a field, compared to the use of composting. Two completely different things. Holds water better, repels insects, reduces weed growth, adds slow release nutrients for plant growth, and it creates airspace in the soil. So in where we live, we have abundant energy, and even to the fact that for us it's really common that when it comes to methane, that we flare off our methane. Not in all places, but it's very common that we do that, and we do that just because we have so much energy that it's just not profitable to mess around with methane. So they just flare it off. But so this is where we have to think about the clients that we're serving and whether they have abundant energy. The other thing, another interesting way to look at this too is that, in our culture, we treat water, which is very expensive. It uses energy, uses chemicals, puts greenhouse gases in the sky. But then we use that water that we treated to flush our toilets. Then we flush our toilets, and then then that water again has to be treated, which uses chemicals, uses electricity, puts greenhouse gases in the sky. So the key is sustainability is a huge issue when we come up with designs. So that's why we just have to think outside the box a little bit. So I've been really fortunate because I've had the chance to go in a lot of villages, especially in Cambodia, and I can almost always tell whether a village has a biodigester in it, even before I ask anybody, because in a village that has a biodigester, there'll be less waste laying around, and it won't be smelly. So before we talk about biodigesters, I want to talk a little bit about C/N ratios, because all this ties in. So a C/N ratio is a relationship between carbon and nitrogen. So our goal C/N ratio for a composting pile is around 30. And C/N ratios are really tricky because if they're too high, then the nitrogen is consumed rapidly by the methogens. But if it's too low, then the high pH will kill off all the methogens. So what we're trying to do, our goal is to try to find a C-in ratio that is in that sweet spot where we can help our methogens, who are my best friend bacteria, by the way, help them so that they can do their job. So this chart, I think, is really helpful. And first thing I got to tell everybody, and I don't want to hurt your guys' feelings, but human waste is terrible for C-in ratios. So just so you know, you guys do a really bad job making waste for C-in ratio. So I apologize that, but somebody had to say it. So if you look on the right side here, you see a bunch of different types of raw material and what the C-in ratio is. So keep in mind, before we were talking about the target being 30, and here we can see that human waste is 8, but straw down there is at 60. So it's interesting that in China and Asia that it's really common where they take human waste and they mix it up with a little bit of straw, just like what we were talking about before. And you can see what they're trying to get to is if you take 60 plus 8 and average the two, then you get around 34, which is that sweet spot of what we're going for. But as you can see here, different kinds of animals produce different types of C-in ratios, and this is an important consideration when you're choosing a biodigester. And also look at the power of sawdust. So it doesn't take much sawdust to really increase a biodigester or increase the C-in ratio. Okay, so this is what a biodigester looks like. This is a model of one. And the way that this works is this is where the animal waste will be fed. Water is also put in here. This is a latrine, and as you can see, it's channeled directly right into the biodigester. This is the dome of the biodigester, and my designs that I've worked with are fixed domes, and I'm not saying that fixed domes are better than floating domes, but fixed domes are, from a maintenance point of view, are way easier than a floating dome, so that's why I favor fixed domes. Then there is a pipe that leads down to a junction box, and then there's a pipe that goes over to the structure. Then when the waste is in here, between here and here, it hangs out in here 35 days, and it works through this system, and then it comes out here. And then once it's here, it's this high-quality bowel slurry, which I have some pictures of. Even though it looks gross, it has no odor, and it's super, super good fertilizers. I've talked to many people, and the farmers, was at the end of my cord there. The farmers love biodigesters because of the bowel slurry, and the ladies of the house love the methane gas because for them it's like a microwave because they don't have to worry about getting the charcoal, heating up the charcoal. They can just turn on the flame and it's right there. So what happens is in Cambodia, the majority of Cambodia is Buddhist, and all households will make food for the visiting monks. So in their culture, you can't have food that is made from animal waste in the process, no big deal. Food that's made that has anything to do with human waste is a huge deal. So biodigesters that are by Buddhist people will not have this pipe here, but Christian organizations will because of what their views are. So this is where it's tricky from a society point of view. And this side view is really helpful to understand how it works. So what happens is you put in the waste here, and the waste in the system is where these red lines are. So there's a lot of pressure in here. So it's this pressure that forces the methane gas up through here and up through the pipe. But every day this is fed, Every day a little bit of waste comes out, so it's just a process. It's a slow-moving process. Some comes in, some comes out. So this is one that I built in Cambodia, in Anglong Vane, near the Thai border. And in this picture, this is where it's fed. This is the dome, the top of the dome, and this is the outlet. But this latrine is tied in with the to the biodigester. So here's a picture of the inlet, and this lady loves the biodigester. Like to them, like they're the talk of the whole area, because this was the first biodigester that was put in the Anglong Vane area. There's a lot of other biodigesters in other parts of Cambodia, but this is the first one in this area. And then I'm sitting on the outlet of it. So as you can see, the footprint is pretty small. And so, you know, people will say, well, biodigesters, they're way complicated. They're so confusing. But, you know, this, I mean, think of this, think of a septic tank, think of a distribution box, think of a leach field. I mean, this stuff is not very difficult. You know, it's just not this difficult. Okay, so I don't want to lose everybody on this one, so give me a little bit of grace here. So this is what the bowel slurry looks like, which looks horrible, but just to prove to everybody that it doesn't smell, I made a poop stick, stuck it in there and smelled it. But what's amazing about this is there's absolutely no odor at all. There's no flies, and the contrast between, like, if you see a cow patty and the amount of flies that are on that cow patty compared to this, it is night and day. So they use this material for farms, and then this is a work in progress, and a lot of people are doing it, even though I don't have studies to show how beneficial it is. But they're using it a lot in aquaponics to feed the fish. And they say that the fish just love this stuff, and it helps the fish grow more healthy than the food that they can buy. So at this farm, we built a fish farm, and this is an experiment that I'm going to do, is have them start feeding the fish this stuff and see how much of a difference that it makes. So inside, it's very simplistic. So these are the burners, and there's a pressure gauge right here. So there's enough pressure to force the methane gas all the way through here. And then all that happens is when they want to use it, they just turn on these valves and light these burners, and then they're good to go. And then you can also use it for lighting as well. Does anybody have, what's some considerations that you think when you see a light like that? The answer is technology. Well, I guess a lack of technology and technology. But the lack of technology is that this little filament in here really doesn't last that long. Just like if you use these for campfires, they don't last very long. But the bigger issue is solar, because now that we have solar, I can't believe how even the most rural areas that I've gone, I see solar, and it's just so easy for people to put in a solar panel and a light to get their light. But what's handy with that gas is it's good backup light. And before we put this biodigester in for these farmers, I mean, once the sun went down, they lived, I mean, it was dark where they were, unless they lit a fire, which usually they didn't, because due to all the deforestation, there's not a lot of wood around. So, and the other thing is, if you have a biodigester, then you can boil water, and if you can boil water, then at least you can be healthy. So the impact of that gas is life-saving. The biodigesters that I've shown so far is a 4 cubic meter size, but it can be scaled all the way up to 20 cubic meters and probably even beyond. But the organization that I'm working with, the contractors that build these things, these are the standard size that they build. But it takes a lot of waste to feed these. So like with a 4 cubic meter biodigester, you need 53 pounds of waste a day and 6 gallons of water. So this is an example of, they have some of these in Haiti, they got some of these in Africa, but they're a lot more common in Asia because Asia has a lot of water. So if you're in a drought-restricted area, these can be pretty tough. So to me, the design of these things could be very regimented, because all we have to do is make tables like this. So even though you can't read the numbers, and I don't really expect you to, but the idea here is that each of the dimensions on here, depending on the size of the biodigester, we can show what the dimensions should be so that the designs can be pretty simplistic. And what's nice about this is that we know many of these have been built, so we know that if we design it with these standards, that we're going to end up with a really good product. And now these prices were last year prices, so I don't know if they've increased. But just so you guys, to me, how cheap this stuff is pretty amazing. But in Cambodia, for a 4 cubic meter biodigester, the cost is $550, which includes the whole system. It also includes 2 years of maintenance. It includes a supervisor looking over the process. And for that 4 cubic meter, you get 2 to 4 hours of gas for cooking, or you can get 8 to 6 hours. It should be 6 to 8 hours of lamp. But so it's up to the user how they want to utilize their the biogas that they generate. So these things pay for themselves really quick because of the cost of charcoal. And plus, it makes the farmers very independent, because in a way they're living off the grid. So as long as they have animals, as long as they can keep feeding it, they can keep generating biogas. Yeah. Probably the most complicated part of the biodigester is this piping, and the organization that we work with has this piping already made up. But you can see that, so this is the top of the dome, and then the gas goes like this, and then there's a kind of a junction right here, and then it goes into the building. But this, you know, it's very flexible on this design. Unlike a septic tank and a leach field, there's a lot of give and take on this, because the gas is going to find, it's under pressure, so it's going to find where it needs to go. And then building these things, I've really enjoyed seeing these things get built because of how good they are at building them. But the typical thing that I've seen is where they have a stick like this that has, and then they put a nail in the center right here. And then with this stick, they use this to place this brick, and then they move to the next one, and then the next one, and they just keep going round and round and round. And then they use a counterbalance on the other end to keep the brick from falling in. So the process is moving the stick around, having this counterbalance here, and just kind of working your way round and round. And, you know, it's really great because these contractors that build these biodigesters are so proud of the work that they do, and they're just so incredibly fast. One of these was built in 5 days while I was there, from breaking the original ground to the whole thing being built, you know, which is really neat stuff. But they take a lot of work on, you know, being really precise and trying to make sure that everything is leveled up really good. So it's a nice thing to see. So after 2 years of operation, because this biodigester now has been in place for 3 years, but last year, and I keep up on it, but I got a call that the gas pressure had decreased, and we found out that the farmers actually were putting up like walls around the burners to keep the flame from burning out. So, but I knew that they were using the same waste, they were using the same process. But the answer is there's a drain valve in the line And the reason why is that condensation will develop in the line after some time. Sometimes it takes a long time for this condensation to develop. I'm talking like years. But so in this case, I was talking to somebody through my smartphone, and I told them to open up the valve and asked them what happened when they opened up the valve, and they said, well, a whole bunch of moisture came out. And I said, well, that's good. And I said, how's your flame now? And they said, oh, it's super strong. It was just like it was when we built the thing. So the point of this story is we got to be really careful that when we design these things, even though we give instructions to the people that are using it, it's hard to remember all this stuff. And so dropping in on the systems that we design every once in a while is real beneficial. And, in this case, I showed a graphic that showed this, a couple of minutes ago. So the answer to the question for us was, very, very was there. But, you can just imagine a farmer that doesn't understand all this technology. Sometimes it can be hard for them to understand all this. So some challenges with a biodigester is it has to be fed every day. It requires water. It's not very good in cold climates. You can use solar to help that situation, and there's a lot of other people like Bill Gates that are trying to come up with technologies to use biodigesters in cold climates. The construction of the dome takes skill, but I would say it's very easy to be done as long as you've done it before, you have experience. There's the appearance that this is a complicated design, which I really think is a fallacy, because I don't think that it's a complicated design. Knowing what I know now, I'm more scared. I would be scareder to talk to a Cambodian contractor about building a septic tank in a leach field than I would a biodigester, because a biodigester just doesn't have all the complicated construction that's involved in it. It takes about 60 days for the biogas to start developing, which can be really frustrating to the user, because the user, when they get these in, they're so excited and they want to start using the biogas all the time, so that they have to be patient. And there's a lot of biodigesters out there that have given biodigesters a bad name, a lot of innovative designs. And I'm definitely not saying that these innovative designs are bad, but the reason why I'm using the particular type fixed dome biodigester that I'm doing in Cambodia is because I know that they've built about 30,000 of them. And in their culture, this is a biodigester that they're used to. So for me to go there and introduce a floating dome biodigester, it's true that it may generate a little bit more methane gas, but the minute that it quits working, nobody's going to know how to maintain it. So this is a real cautionary tale of with water and wastewater, it's like voodoo engineering. There's so many different techniques to treat water, and there's so many different techniques to collect methane. But you just have to be really careful. And something that I've learned, because I've gone on a lot of EMI trips, and to be honest with you, I have a lot of regrets about designs that I've done in the past that I think could have been done better, which is what leads me to want to do presentations like this. But just really think about how it's going to be used, not just in the short term, but in the long term. So this is what some of these innovative designs look like. And here again, I'm not saying that these are bad, because if you're in a place where everybody is using these and they're part of the culture, then they could be okay. But these plastic bag types, it's really common that they leak. There's just a lot of negativity if you look on the web about these things. I really like Water for World, and Water for World has some really good suggestions for designs. But the Water World design for a biodigester is so confusing and so convoluted that I don't understand it at all. And so this is one example of where I wouldn't use Water for World for biodigester designs. But if one of you guys figure it out and you think that it's great, then send me an email.
What's the advantage of the floating dome versus?
The floating dome, it rises and lowers, so it can give you a little bit more constant supply of methane gas. And but the problem is then it has rollers. It has movable parts. Where see a fixed dome it doesn't move at all. So yeah. So in conclusion, research to find out what works in the area, and take time to find out if there's existing organizations that are trying to achieve the things that you want to achieve. I've been working with the National Biodigester Program and developed some really good relationships. The main guy that I was talking to was a Muslim. He was a Buddhist. But he has been, whenever I'm there, he always attends the church events with me. And it's very enjoyable because sometimes I kind of take a peek at him, and when he's seeing all the little children singing and having fun, it makes me realize that we're really building culture in a great way. There's more to waste than designing a septic tank and leach field. Even though those can be the appropriate design, there's no doubt about that. We need to use every available tool that we have. I like this line: when all you have is a hammer, everything looks like a nail. And that's kind of the classic way that us engineers will design things. Human and animal waste can be a valuable resource, and it can generate beneficial fuel. Keep in mind that in my talk, I've not talked about the production of electricity, and you can use biodigesters to produce electricity, but that's so much more complicated than the simplistic design that I'm showing everybody. And we need to look beyond our Western culture and engineering experience when finding solutions. So my last slide, which personally I think is my greatest slide. Okay, so in leaving, I want everybody to at least know how to use the bathroom. And these are actual pictures that I've gotten out of restrooms that shows how to properly use a toilet. So just so you guys know, don't do this. But what's ironic about this picture is, like, where to us this is really funny. If I ask a lot of people in America how to use a squatty potty, they wouldn't know how to use a squatty potty. So this is even though this is supposed to be humorous, there's a deeper thought here, which is that we got to be really careful with putting our views onto other people's cultures and not recognizing the difference. Okay, well, anyway, thanks for coming.